Hi people, notes 3.2 are on key properties of a parabola, and if you notice there are 6 different key properties that we're going to talk about. They're defined for you, and then we're going to use this graph up here to help us with our examples. So the first key property is the axis of symmetry. This is what we'll look at first, and it is a vertical line that cuts the parabola into symmetrical halves, and it's always going to be an x value, so that's really important that it's an x value. So for example, right here, if I were to draw the line that cuts this parabola in half, it would look right here in this spot right here. So this line right here is called the axis of symmetry. And because it is a vertical line and it intersects where x is 1, we can say here that the equation of the axis of symmetry is x equals 1. The next thing we're going to look at is the optimal value. And the optimal value is either going to be the highest or the lowest y value this time that a parabola reaches. Sometimes it's going to be the highest point, sometimes it's going to be the lowest point. In this example, it is the lowest point. Because this graph goes on forever up to positive infinity, but this right here is the lowest point. Sometimes if it looks like this, then it will reach its highest point right here. So this is the lowest that the graph reaches, so this right here is called the optimal value. Okay, and this occurs where y is equal to, since this is -10, it's going to be -9. And then the vertex combines the axis of symmetry and the optimal value. So the vertex actually occurs at this specific point right here. And the coordinate is going to combine the axis of symmetry with the optimal value. So the one with this -9. So this right here would be 1, -9. And because it is the lowest value that we would see, this is called a minimum. If our parabola looked like this, then our vertex would be called a maximum, okay? The next key feature is something called the roots or the X-Intercepts, okay? So the roots are the value or the values of x that make y equals 0 in the graph. So it's where the parabola hits the x-axis, because if you look right here, on the x-axis right here, this is where y would be 0. So in this example here, my 2 roots would be at these 2 points right here. This is where it hits this x-axis right here. Here's my x-axis, here's my y-axis. So I can see here that it hits the x-axis at -2 and at +4. So we can call these right here your roots or your x-intercepts. The only thing is that there are 2 different notations. So for roots, they are just the x value. So you would say x equals -2 and x equals 4, or we could write it as a set and say it's -2 and 4 like this. If you notice, it's just a single number. But for x-intercepts, we have to write them as coordinates. So our x-intercept would be at -2, 0. And the reason why it's at -2, 0 is because the x value is -2 here, but the y value here is 0. And then the other one is 4, 0. Again, same thing, the x value is 4, the y value is 0, and the y value will always be 0 because it's always going to hit the x-axis and y always equals 0 on the x-axis. Or if you were to write it in set notation, then it would be -2, 0 and 4, 0, like this. Now, for the roots or the x-intercepts, you can have 2 roots. You could have 1 root, you could have no roots. But for the y-intercept, which is the next one we're going to look at, there's only one answer here. So actually we'll just say y-intercept here. And it is the value of y that makes x equals 0 this time. So this time it's where the parabola hits the y-axis. So if I look right here, if this is my y-axis, then I can see that the parabola is going to hit the y-axis right here. So this point right here is called my y-intercept. And because it is an intercept, we have to write it as a coordinate. So it'd be 0, comma, because the x value on the y-axis is always 0. And this right here is at -5, -6, -7, -8. So this right here would be 0, -8. Okay, and then the last key feature is whether the parabola opens up or down. And that comes from the a value, which is the a value, the exact same a value that we talked about when we factored by decomposition. So if it opens up, the a value is positive. If it opens down, then the a value is negative. We'll talk about that more in detail shortly, but we also know it opens up just from this graph because as you can see right here, this parabola has its opening up on top, so we call this opening up. So in our example, we're going to say that this opens up. So those are the key features, the key properties of a parabola. Let's go ahead and now apply that to an actual parabola that we still have to graph out. So here we're going to graph the following quadratic relation by creating a table of values. Now sometimes you have to do it using a table of values. There are other methods to graph out these parabolas. We're going to learn these different methods throughout this unit and the next unit. But let's go ahead and talk about how to graph it using a table of values. So here, if my equation is y equals 2x squared minus 4x minus 6, if you notice here, my first x value is negative 2. So that means I'm going to plug in negative 2 every time I see an x. So I'm going to say 2 times negative 2 squared minus 4 times negative 2 minus 6. I'm going to fill these all in here with negative 2's. And then I'm just going to evaluate. So here, this becomes y equals 2, negative 2 squared is 4, positive 4. And then I'll copy the rest down. And then here I would get 2 times 4 is 8, negative 4 times negative 2 is positive 8, and then subtract 6 from that. So I would end up getting 8 plus 8 is 16, minus 6 is 10. So this y value here would be 10. Let's do another one. So here I would do y equals 2 times something squared minus 4 times something minus 6. I'm just using this right here. But instead of x, I'm going to replace that x right here with the next number, which is negative 1. So say negative 1 squared minus 4 times negative 1. So here I end up getting negative 1 squared is positive 1. I'll copy the rest down. And then 2 times 1 is 2. Negative 4 times 1 is positive 4, and then minus 6. 2 plus 4 is 6, minus 6 is 0. Okay? Now, this will get tedious to do all of these lines of work every single time. So for the next one, I am going to plug it in, just like we did before. So here I'm going to say y equals 2 times 0 squared minus 4 times 0 minus 6. Except now I'm just going to do it all in a couple of lines here. So here, 0 squared is 0, and then 0 times 2 is also 0. Negative 4 times 0 is 0, and then minus 6. Subtract the 6 from 0, I get negative 6. So this here would be negative 6. Let's go ahead and do the next one. Here I've got a 1. Here I'm going to replace the x with 1. 1 squared is 1. And then I get 2 times 1, which is 2, and then negative 4 times 1 is negative 4, and then subtract 6. 2 minus 4 is negative 2, minus 6 gives me negative 8. I'll do the next one over here, just because of space. So my next value that I'm going to plug in is 2 here. So I get 2 squared, and then 4 times 2. 2 squared is 4, so then I multiply that by 2, I end up getting 8. And then negative 4 times 2 is negative 8, minus 6. 8 minus 8 is 0. 0 minus 6 is negative 6, so I would get negative 6 right here. And I'm just going to have you do the remaining 2 values on your own. Pause the video, see how you do, and then come back and check how you check your answer, okay? So the next 2 values you should get are 0 and 10. If you did not get those values, just write a little note on the side right now and then ask me next time I see you in class. Okay? So now let's go ahead and graph out this parabola. So this is literally my coordinate. So it means negative 2, 10. So I'm going to go to negative 2 on the x-axis right here. And then I'm going to go to 10 on the y-axis. And then I'm just going to put a dot right there. So this is negative 2, 10. My next value that I have is negative 1, 0. So I go left 1 and I don't go up or down. The next value I have is 0, negative 6, so I don't go right or left, but I go down 6. Then I have 1, negative 8, so right 1, down 8. 2, negative 6, 3, 0, and then 4, 10. And then I'm just going to connect the dots. Now, just a reminder, when you have a parabola, it needs to be a nice, smooth curve. Don't make it look like a V. And here's my parabola right here. And then we can just go ahead and label all of our key information here. So our axis of symmetry is the line that cuts the parabola down the middle. So this right here is my axis of symmetry. So it would be x equals 1. And if you notice in this chart right here, when x was 1, I ended up getting -8 for my y value. So that is my optimal value right here. And then the vertex would be the coordinate 1, -8, which is a minimum because my graph opens up. Okay, we'll talk about that again in a second. But if you notice right here, it is symmetrical around this point right here, just like the graph is symmetrical around this point right here. So the -6 matches up with -6, 0 matches with 0, 10 matches with 10. And now I want to go back to the idea of the direction opening up. So if you remember on the previous page, we said that if A is positive, it should open up. And here our A value is 2, which is a positive value, which is why our parabola will always open up. If A is negative, it will open down. Next, we need to find our x-intercepts if there are any. And we actually have 2 x-intercepts. And because this says x-intercepts, we have to write them out as coordinates. So my first x-intercept occurs at -1, but I have to write it as -1, 0. And then my second x-intercept occurs at +3, so it's +3, 0. Okay, and then lastly, we have our y-intercept, which occurs at -6. So our y-intercept is 0, -6. We can tell that our y-intercept is 0, -6 from our chart right here because it occurs when x is 0. And we can tell that our x-intercepts are -1, 0, and 3, 0, because when we plug in -1 and 3, our y values end up being 0. One last thing that I want to say is that we have to label the equation on our graph. So we're going to write y equals 2x squared minus 4x minus 6, and we are done with this question. All right, in our next one, it says graph the following quadratic relation by creating a table of values again. So here, my first value that we see here is -3. So the exact same idea, I'm going to say y equals negative. Now listen very carefully to what I'm about to say here, because this is where people will mess up. So if I have a negative number that is being squared, like for example up here, I had this -2 is being squared. I had to put it in brackets to show that the -2 is being squared. I'm doing -2 times -2. Without brackets, what I'm doing is I'm doing 2 times 2, and there's just a negative hanging out. But with the brackets, we're saying that it's -2 times -2. So anytime you have a negative number that needs to be squared, it has to be in brackets. Now for this one right here, this one's tricky because the number that's being squared is -3. We're going to square that -3. I'll write the +4 here, but then this negative also goes in front. Okay, because what this technically means is that we're doing -1 times x squared. There's an invisible 1 in front right here, and we have to square the number first. We have to square that -3 first before we add on that negative. So for example here, -3 squared becomes +9, but this negative tags along. Or you could look at it like -3 squared is 9 times -1 is -9. Okay, and then we just add the 4 onto it, so we end up getting -5. So here, when x is -3, y is -5. Let's try the next one. So here I'm going to do y equals negative, and then I'm going to do replace the x value with a -2 right here. But -2 squared is +4. The negative just tags along, and then I get -4 plus 4, which is 0. So this right here would be 0. Let's try the next one. Y equals negative, and then in brackets, -1 squared. -1 is the next value I will fill in here. So I'm going to say -1 squared, which is +1, but then the negative tags along right here, and then +4. So -1 plus 4 would give me +3. For the next one, I have y equals, here I've got negative, and then in brackets, I'm going to put in that 0 here. So I'm going to say 0 squared. Well, 0 squared is 0. We sure can add in that negative if you want, but -0 and +0 are the same thing. It doesn't matter. 0 plus 4 is +4. Okay, let's do one more together. So y equals negative, and then here I'm going to replace the x value here with +1 inside of here. But if you notice, when I do that, there's still a negative in front, okay? But it's outside of the brackets still. So +1 squared is 1. The negative tags along, +4, and I get y equals 3. So we can say that this is 3. Please determine the remaining 2 values. Pause, do the values, come back and check with me to see how you did. And if you have any questions, let me know next time I see you in class. So the remaining 2 values are 0 and -5. Hopefully you have noticed the pattern that the 4 is in the middle, then it went 3, then it went 0, and then it went -5. Okay, let's go ahead and graph out this parabola. So the first point is -3, -5. I'm going to go to the left 3, down 5. Next point is -2, 0, left 2, and then I don't go up or down at all anywhere. Then I've got -1, 3, 0, 4, 1, 3, 2, 0, and then 3, -5. So here, this is what my parabola is going to look like. So sometimes your parabolas will be right side up with the opening on top. Sometimes your parabolas will be upside down with the opening on the bottom. Here, this time our axis of symmetry is right down the middle. So we're going to say here that our axis of symmetry is at x equals 0. And the optimal value that we reach, the highest point that we reach here is at 4. And that's the y value. So we'll say y equals 4, which means combined together, my vertex would be 0, 4. But this time it's the highest point, so it is a maximum. Next thing I want to look at are my roots. So right here, my roots will occur on the x-axis. This time, my roots have to be written out as just single numbers because it's a root and not an x-intercept. So my answers are x equals -2 and +2, because you can see that's where they cross the x-axis at. And then the y-intercept occurs at 4. This is at 0, 4. And this time our parabola is going to open down. By the way, every time it opens down, we have a maximum, and every time it opens up, we have a minimum. How would I know that it opens down just from the equation without even graphing it out? Here, if you notice, the a value is -1. So the a value is negative, which means it's going to open down. All right, let's take a look at the next page, determine the key features of the parabola shown below. So this time we have 2 more parabolas. We're just going to go through this pretty quickly because there's just a few more situations that I'd like you to be aware of before you get some practice. So our axis of symmetry for the solid parabola is going to be right down the middle right here. This is going to occur at x equals, this number right here is at -3, -1, -2, -3. The optimal value here is going to occur when y is 0. So here, the highest it reaches is 0. And the vertex is at -3, 0. This point right here is at -3, 0. And because it is opening down, it's reaching its highest point. It's a maximum. Now, if you notice, the x-intercept and the vertex ended up being in the exact same spot, and that's okay. So I just wanted to show you an example where you might have the same vertex as the x-intercept, okay? And then our y-intercept is right here. It is at 0, -9. And the direction of opening is down because it opens at the bottom. It's upside down. It's an upside down parabola. Okay. Quick note also, the vertex could also occur on the y-intercept as well. So for example, if you look right here, the vertex here happened on the y-intercept. So sometimes it'll be a completely separate point, like over here, where the vertex is completely separate from the x-intercept and the y-intercept. Sometimes it could be the exact same thing. All right, in our last example, I'm just going to do it all up here and then I'll copy the information down. So our axis of symmetry is going to occur right here. This is going to occur at x equals +3. Our optimal value here is at y equals 2, which means that our vertex will occur at the point 3, 2, and this is going to be a minimum. So here, let's just fill in that information. X equals 3, y equals 2. The vertex is at 3, 2, and this is a minimum. Now let's talk about our roots, our y-intercept. So here, if you look, our graph does not touch the x-axis at all. It starts above the x-axis, it goes down, it reaches its, by the way, the vertex is also called a turning point. So it reaches its turning point, and it's called that because it turns back around and it never makes it to the x-axis, which means that there are no roots. Okay, and then the y-intercept is going to occur at 0, 5. So we say that there are no roots. The y-intercept is at 0, 5, and this time the direction of opening is up because it's open on the top. And that's it for this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.